In this video, we're going to go over universal gravitational law. So we will learn what is the formula for the force of gravitation, what are all the different variables inside of this formula, and as well as look over two very common, very typical examples that you should definitely know if you want to succeed in this unit. So let's firstly start by examining what is the formula and what is the gravitational force. So gravitational force is an attracting force between any two masses. The situation where it applies is, of course, where you have two objects that have a mass, right? The direction of this force is always pointed towards the other mass. And in just a minute, once I draw the sketch, it will make sense what I mean here when I say the direction. I find this formula kind of romantic because it means that there's force between any two objects that have a mass, right? So for example, you that is watching this video and me sitting across the camera, there is a small gravitational force between us because you have a mass and I have a mass. Therefore, you can calculate the gravitational force, and even though it will be really, really small, it is not zero, right? Well, with this in mind, let's take a look at how would you calculate that force. So the formula for the gravitational force F is equal to G, which is the gravitational constant. So it's simply a number that always stays the same, 6.67, 10 to the minus 11. And you will be given this number either in this problem or on your formula sheet, times M1 times M2. So M1 and M2 are the two masses, right? So an example I was telling you is M1 would be your mass and M2 would be my mass, which I will not tell you. And D will be the distance between centers of masses of these two objects. So distance between the objects. And I will explain what I mean here by centers, distance between centers of masses specifically. But first, let me draw a sketch, right? Because we need to know where these forces will be pointed. So if we have two masses, M1 and M2, the force on M1 will be pointed towards the other mass. And the force of M2 will be pointed towards the other mass over here. And these two forces, there should be, so this is what I meant right here when I said always pointed towards the other mass, right? Because force of gravity is an attracting force. Now, what did I mean here when I say between this, the distance is the distance between center of masses? Well, instead of plugging in the distance between the surfaces, right, of the spheres, for example, you should look at the distance between their centers, right? And that's going to be the distance that you would plug into the formula. This is going to be especially important in the next video once we start looking at examples of satellites and planets, right? And planets have basically quite big radiuses, right? So it's going to be important. The distinction between centers of masses and distance between the objects is going to be pretty important. Okay, now that we have figured out and we have learned what is the formula, let's practice it by going over two really quick and common examples. So the first example is going to be pretty straightforward. It's just going to be plugging it into the formula. So we have to calculate the gravitational force between two students, one with a mass of 80 kilograms in Thailand and another student of 50 kilograms in United States. You can assume that the students are directly opposite to each other and positioned approximately, so distance is twice the radius of the Earth, right? They're basically on the opposite sides of the planet. And we're given the radius of the Earth is equal to 6,400 kilometers. So in any physics problem, right, before you even write any equations, anything, if any of your units are not in standard SI units, meaning, for example, then you have to convert it to standard SI units. That is into kilograms, meters, seconds, etc. In this case, it's the 6,400 kilometers, right? We need to convert that to meters. So remember that 1 kilometer corresponds to 1,000 meters. So you have to multiply this number by 1,000, essentially adding 3 zeros to this number. Now, this is not the best kind of, this is not the most convenient number to write, right? Because it's very big. So let me write this in scientific notation. That is, let me write this number as 6.4 times 10. And let's see, how many decimal? 1, 2, 3, 4, 5, 6. 10 to the 6th power right here. If you have a problem with scientific notation, I do have a video. It's a very first video that explains how to deal with scientific notations. But now let's find the distance, because this was the radius of the Earth, which is 2 times 6.4 times 10 to the 6. 2 times 6.4 is just 12.8. Which, if we want to be correct, right, we can just take one decimal point away from here and write this down. Okay, perfect. You can also, right, on your calculator, you can go to mode, right, and there is basically a setting to set your calculator. Instead of normal, you want to set it into sci-fi. That means the scientific notation, right? And if you input this number, it will automatically essentially convert it to scientific notation, right? Just be aware that the calculator is going to give you 6.4 E6, which means this E means 10 to the power of 6. All right, so now that we have all our inputs, right, we just have to plug this into our formula. So the formula for gravitational force is G times M1 times M2 over distance squared. G is just a constant that is equal to 6.67, 10 to the minus 11. M1 is 80 kilograms, M2 is 50 kilograms, and distance between the two objects we found was this, 1.28, 10 to the 6. So try to plug this into a calculator yourself, because you should actually, even though it's pretty straightforward, right, you should practice it, because you need to be aware of the parentheses. So it's it takes some getting used to dealing with these like really large numbers. But you should get 1.63, 10 to the minus 21 kilograms, right? Just a few quick calculator tips before I move on to the next problem, right? One is, I would definitely advise you to set your calculator by going to mode and set in scientific notation, because we're going to be dealing with really big numbers in this unit. The second thing, right, is that the part where most people make errors, if you didn't get the same answer, is with these powers. So you can write 6.67, 10 to the minus 11 as the following. On your calculator, right above the 7 button, there is a comma, right? If you, for example, are using TI-83 or TI-84. And above it, it says EE. So if you press second, so let me write this first, 6.67, first you write this. Then if you press the button second on your calculator, and then you press this comma button together, the calculator should give you E. What it means, this E is a shortcut for 10 to the power of. So you can write 6.67 E and just put the power. So this will really help you a lot when you put this into your calculator, and make sure that you avoid any potential errors, right? Great. So now that we calculated this, let's take a look at the next example. So problem 2. Well, we have to calculate the gravitational acceleration on the surface on the moon. So let's say you're part of planning a space mission, right? And you need to calculate what gravitational acceleration will astronauts experience on the moon. And what you have is the mass of the moon, which is 7.35, 10 to the 22 kilograms. And you have the radius of the moon, 1.74, 10 to the 6 meters. Now, we'll start this question just as we've started all our examples in previous units, by the second Newton's law, F net is equal to ma. So if you are in, let's say, gravitational free fall, right, you're just basically a falling object, and the only force you're experiencing is the force of gravity from the moon, then the F net, your force, will be just the gravitational force itself. So it's your mass, m, times the mass of the, let's call it moon, times the mass of the moon, over the distance, the radius of the moon, is equal to ma. So ma, since you're writing this for whatever object is falling, let's say it's you who are falling on the moon. So mass over here, your mass, right, is canceling out. So here you have the expression for acceleration, gravitational acceleration on the moon. We can plug in G, which is 6.67, 10 to the minus 11. We can plug in the mass of the moon, and divided by the radius 1.74 10 to the 6 squared. So if you plug on that in the calculator, remember this trick, right, about writing it as e to the minus 11 by clicking second and then comma. So this is a faster way, right, to a faster and easier way to write these big numbers. If you calculate all of that, you'll get an answer of 1.62 meters per second squared. So try this on your own on your calculator. So in this first video on universal gravitation, we looked over two really simple examples and the formula. And in the next video, we'll go over a very, very typical problem that I'm sure will show up on your quizzes or tests of how to calculate velocity of the satellite and orbital velocity. So keep watching and keep practicing. Hopefully this was a very helpful introduction. Have a good luck. Have a good day.